So folks, on this pink sheet, what we're going to be doing is every problem except for the last one on the back, number 6, to get us ready for the quiz. So I'd like you to go ahead and take out your yellow formula sheet as well. And on the yellow formula sheet, don't forget that you have to have memorized that I equals R over M. And I just want to tell you that on this future value of an ordinary annuity formula, I noticed that on some of the homework, oh no, it was on the annuities due one, where you've got this N plus 1. I've got some people who are adding the plus 1 to just the M or to just the T. When I use N is equal to MT, it's MT plus 1 for that one. So just be careful and make sure that you're not trying to do too much in your head. I usually like to write the formula out in terms of M and T first and then start plugging in those values. So it's the number of payments times the time, and then you add 1 to it because you've got that additional period of interest when you're doing your payment at the beginning versus payment at the end. So just be careful on that one. The quiz today is going to be all somewhere in the future value problem. So you're only going to be using those middle 3 formulas. So something to be thinking about. Remember that ordinary annuities, payment at the end, annuities due, payment at the beginning. And if I am solving for R, it is automatically a sinking fund question. So I'm never going to give you a solve for R problem for an annuities due, just because again that formula is pretty nasty, and if you were to solve that for R, it's a really wild looking equation. So anytime you are solving for R, you can assume that it is a sinking fund. These two equations are the exact same thing, but this one's a rearrangement of that one for R, this one is a rearrangement for S. And again, folks, we started talking about present value. The last 2 formulas on here, none of the problems on the quiz deal with these, but it is good practice because on the test, we are going to be putting all those formulas together just to be aware of. Anytime it's mentioning saving up for something or something in the future, we are solving for S. So that's kind of a breakdown of the formulas you are going to be using. And what is our unit for T? Always. Years. So, Isabel was asking about a question on my math lab, and it's like 6 quarterly payments. So quarters would be our M, but how many years is 6 quarterly payments? That means we're doing 1 full quarter, 1 year, and then 2 more quarters or a half of a year. So just be careful with the wording on these problems. If you want, you can go through and find all your M's first, or you can find all your times first, whatever is going to make it so that you remember all of those little details. So folks, we're going to go ahead and jump right into this first example. And as we are doing these, keep in mind what variables do we have? / want. That's going to be key for figuring out which formula we are using and what variation of it. Now, on the on the quiz, I want you to show 1 step of work and then round using the correct unit. So are you solving for the rate? Is it a percent? Is it time? Are you solving for years? Is it money, where you are rounding to 2 decimal places? So make sure you are rounding correctly and also show 1 step of work. So you don't have to write the blank formula, but you do have to show me the formula with the values plugged into it. That way I can give you points for 1, choosing the right formula to use, 2, plugging in the right values for those variables, and then 3 for your final answer. So that's what I'm looking for as far as work goes. So on this first problem, it says, what is the future value of an ordinary annuity that has regular payments of $4,600 at the end of each quarter for 9 years if the annuity earns 8.73% interest? All right, folks, so it's asking for the future value. What variable is future value? Always S, the somewhere in the future value. So we're looking for S. Now, it tells us straight up that this is an ordinary annuity. So which of these ordinary annuity expressions do you think we're going to use if we're solving for S? The future value of an ordinary annuity. So we're going to be using this formula. So something to keep in mind as we go through this problem. Now, even if it hadn't told us explicitly that this is an ordinary annuity, we would have known that that's what it is because they tell us that the regular payments are made at the end of each quarter. Now, the 4,600 is going to be our R. Each quarter tells me my M is 4. That means 4 times per year. And then 9 years is our T. 8.73% interest, 0.0873. All right, so that's the first battle, is picking the formula we're going to use, deciding on what variable we're solving for and what variables we know. And now it's going to be plugging those into our equation. So I'm going to go ahead and see if I can get this all on one screen. There we go. There's the future value of an ordinary annuity. So S equals, that's what we're looking for. Our R is the 4,600. Bracket 1 plus, what's I equal to? R over M, the rate, 0.0873. Divided by our M, which is 4. Raised to the N, which is the M times T. So the amount of times you're making a payment per year, which is 4 times, and then times the time, which is 9 years. And then minus 1. Okay, folks, that minus 1, it's really easy to forget about, so be aware of that. And sometimes, folks, students will have it in their work, and they'll still forget to put it in on their calculator. So we're going to be taking this quiz after lunch. I think I'm just going to give you a solid half hour to work on it, and then we'll jump into the rest of our notes for today over amortization tables. So you'll have plenty of time to work and make sure you're doing all that data entry correct on your calculator. All right, folks. So let's go ahead and type this in on our calculators. Approaching it from PEMDAS, where we want to start inside the parentheses, so inside the innermost parentheses. So 1 plus 0.0873 divided by 4, raised to the 36th power, minus 1 next. That gives me my top expression. Now, what happens when I divide by that bottom? What do we need? Parentheses around that fraction. So 0.0873 divided by 4. And final step, and this is an easy one to forget about too, we multiply it by 4,600. And that gives me a big whopping S value of $247,000, 752, and how many cents? 70 cents. All right, folks, so that is our somewhere in the future value. So if we make those monthly payments and we get that interest, that's how much we will have in the account. Any calculator issues on that one? And again, folks, this is why I'm requiring that you show this work, because lots of little places that you could go wrong on your calculator. I do recommend that you do it step by step and don't try to put the whole thing in on your calculator. That can cause issues with parentheses. So just a little tip on how I would go about working these. Now, problem B says, how much of this, so how much of this amount is stuff that we were putting in every single quarter? So how much is from contributions? That's asking about our regular monthly payments. Now, what was our regular monthly payment amount? The 4,600. How often were we making that payment? Every quarter, so times 4. And for how long did we do that? 9 years. So 4,600 times 4 times 9, our MT. So when it asks about contributions, it's asking about your regular payments that you are making into that account. So that gives us $165,000, $165,600. So those are our total contributions. Now C is asking for how much of the value is from interest. So after 9 years, I've got this total amount in the account. This is how much I was putting in every single quarter. What's the rest of it made of? Interest. So interest that it's just making sitting in that account. So how do I find that interest? By taking the total account balance minus our own contribution. So we're gonna take 247, 752, and the cents, 0.7, minus 165, 600. And that gives us, for the interest, $82,152.70. I do not like that decision I made to write that in yellow, but it's fine. So that is our interest amount. So these three working pieces are very important with any annuity. It builds interest and we get this large amount in the future. And then to find out how much we are putting in, it's the payments we're making into the account times the payment periods times the time. And then the interest is the subtraction of those two. So folks, I'm gonna go ahead and see what you guys can do with number 2 and number 3. I'll give you a couple minutes to work on those and then we'll regroup. So first question, which variable are we solving for? On number 2. We're solving for R because we're looking for the amount of money that we should pay in each year so we can accumulate that amount. So folks, which formula are we going to be using if I'm solving for R? It has to be a sinking fund. So that tells us we're going to use that middle equation. See if you can do the setup, keeping in mind that your M is going to be 1. All right, folks, so on number 2, this is what your setup looks like. And on this problem, this is one where I would evaluate the top of the fraction first, then the bottom of the fraction, and then handle your division, which gives you a regular payment of $497.68. Raise your hand if you got that one right. Okay, wonderful. If you didn't, it's really easy to forget about that -1. Make sure that you did it in the proper order of the top of the fraction, then divided by the bottom of the fraction. And just remember, folks, we want to use those stored values on our calculator because we never want to do any of that intermediate rounding. So looking at number 3, we'll go ahead and start this one together. It says, find the amount of each payment. Amount of each payment. What variable are we looking for? The R value. To be made into a sinking fund. Oh, sweet. It tells us that's the formula we're going to be using. So that enough will be present to accumulate to the following amounts. Now, folks, on the test, sometimes students are like, oh, it said present in the account. Does that mean present value? What do you guys think? No, it's going to be there, present in the account, but in the future. So again, the wording of these is really tricky sometimes. So just slow down, read the question carefully, and really think about what it wants. So present to accumulate the following amount. So accumulate means in the future. So payments are made at the end of each period. Again, anytime you're solving for R, it's automatically going to be that sinking fund. It's automatically going to be an ordinary annuity, but this just solidifies that. So the $65,000, that's going to be our S amount. This is somewhere in the future. We've got 0.075% compounded quarterly. M is 4. And T, what are we going to use? 2.5. All right, folks. So using that formula, we are going to have R equals S, which is our somewhere in the future, that's 65,000, times I is rate divided by the compounding period, so 0.075 divided by 4, so compounding periods or payment periods, and then 1 plus R over M, 0.075 divided by 4, raised to the 4 times 2.5. Now that -1, is that at ground level or is that up in the exponent? Ground level. So don't get that -1 confused with this +1. That's actually up in the exponent. So that -1, I'm going to make it nice and big, showing that it's at ground level, not an itty-bitty little exponent. All right, folks, I'm going to turn you loose on this one. Type this sucker in on your calculator and see what you get. And there's the top. $5,970 and how many cents? 23. So don't forget your rounding rules. That was an issue for some of us on that first quiz. Look at the third digit. If it's a 5 or more, like a 9, that's enough to bump up the ones, or not the ones place, well, the 1 cents place or the hundredths place in your decimal. Now, folks, if I wanted to just think accuracy-wise, does a $5,970 seem like an accurate way for me to get all the way up to $65,000? What if I got a regular payment of 20 cents? Not reasonable. What if I got -100 as my regular payment? No! So sometimes you're going to be able to catch some of those calculator mistakes or oof, I done goof somewhere just by thinking about accuracy or does my answer seem reasonable? Folks, any questions so far? Alrighty. Let's go ahead and move on to number 4. You make payments, deposits of $1,500 on the first day of each semi-annual period. This means I'm making those payments when? At the beginning. So this is our first brush on this sheet with annuities due, where payments are at the beginning. So first day of each semi-annual period. So that means Annuities due. We are given the amount of the payment. So this $1,500, those are the payments or deposits that we are making regularly into the account. Now, the account earns 5.6% interest, so 0.056 for that working decimal. How much money will be accumulated after 11 years? All right, folks, so using that annuities due formula, this is the really fun one. It's super fun to use, it's super fun to write, and it's super fun to put in your calculator. It sucks. This one is probably the worst one on here that usually leads to the most mistakes. And again, folks, sometimes students will have it written down correctly on the paper, but just won't enter everything in on their calculator. So let's go ahead and start with plugging in the variables we know. So we are looking for S, how much money will be accumulated. Our R, the regular payments, you guys can't see that. The R, the regular payments, is the $1,500. And then 1 plus I is R over, ooh, what's our M for this one? How often are we making those deposits or payments? The first day of each semi-annual period. Semi-annual means M is 2. So M is 2 there. So R over M. Now here's the tricky part. On your formula sheet, it says N plus 1. So we're going to raise it to the M2 T11 plus 1 power. That minus 1 is at ground level. That's why I like to make that nice and big. And then all over 0.056 over 2. I'm missing something. What is it? Minus R. So that annuities due one is probably the most annoying formula. We have to remember to subtract an additional R. We've got that annoying plus 1 up here. We've got the minus 1 at ground level. And we got to remember to put those parentheses around the denominator. And as you're typing it in carefully in your calculator, trying to follow those PEMDAS rules, it's really easy to get mixed up. So I want you guys to just try this one on your own first. See if you can do it without any assistance from me, and then we'll regroup and go through it step by step. And to give you a hint, you should be getting something between $40,000 and $50,000. Raise your hand if you're done. So S should be equal to 46,000. 034.09. $46,034.09. Raise your hand if you got that one right. Should we go through this one? Are you guys okay? It's step by step, so inside parenthesis, then the exponent. And folks, again, show every single part when you're plugging into the formula. If you want to look at that and then put 23 in your calculator, that's fine. But just from some of the questions that I got on my math lab last night, I know that it's easy to make this 12 and then think it's 24 instead of the actual 23. So again, careful with your PEMDAS and your exponent as well. Then we subtract 1. Then take that item divided by this item in parentheses times 1,500, and then don't forget to subtract that 1,500. So I'm going to put lots of stars by this. All right, folks, let's go ahead and go to the back. Oh, that's not us, is it? Oh, but we're getting real close. We'll see if we can squeeze in this last problem. Folks, number 5. Laura Campbell deposits $12,000 at the end of each year. What does that tell me this is? At the end means ordinary annuity. She is making deposits regularly of $12,000 at the end of each year. That's going to be our R, the regular payments. For 9 years, there's our time into an account paying 8% interest compounded annually. Our M is 1. So the payments are made annually, the interest is compounded annually, M is 1. Find the final amount she will have on deposit. What variable are we looking for? Looking for S. Turning you loose. 1, 2, 3, go. Remember, ordinary annuity, not annuities due. Should be getting something between $140,000 and $150,000. Careful when you're turning those rates back into working decimals as well. I think it was during class yesterday. It was actually one of my pre-calc kids because they're doing stuff with percents too. They're like, oh, I never remember how many places to move the decimal or which way I'm going in what direction. Folks, taking 50% of something is the same as taking a half of that. What's 50% as a working decimal? 0.5. If you can remember this relationship, it will tell you to turn it into a percent. We move it 2 places, and to turn it to a decimal, 2 places to the left. So this relationship can help you and be significantly important because sometimes the ACT will throw stuff like this at you. And it's like, oh no, it already is a decimal, but it's within the percent. So when it's a little less intuitive, just remembering 2 places to the left when you're going from percent to decimal. All right, folks, let's go ahead and see how we did. Oh, I thought I had it frozen. Just kidding. Anyone have any trouble getting this one? All right, super duper. Also, I was going to ask before we break for lunch, does anybody want me to charge their calculator in my dock? And I'm asking because I know that your calculator's probably been fully charged since you got it or since whenever. So if you don't want to track down a charger at home, I got a dock back here. So again, if you want me to charge your calculator, if you're getting kind of low before we break. And a reminder that some of these ones, they do have a port where it looks like they can be charged, but always check for that battery panel on the back. 4 AAA batteries for those calculators. All right, folks, we're going to see if we can quickly go through this one. Oh, actually, maybe not. You guys feel all right about this? Mm-hmm. If you want to study from this over lunch, you can. Otherwise, crumple it up and throw it at the trash can. So, quiz after lunch, 30 minutes, sinking funds, annuities. Then we're going to do some amortization of loans, notes, and then home free for the weekend. That last My Math Lab won't be due until Monday, and we'll probably have some work time on Monday for that as well. Test is still tentatively planned for Wednesday.
Got another shot.
So I'm going to be optimistic and say yes, test on Wednesday. I hope it's woo! We got these little star obstacles hanging down the ceiling.
Wade got it. Threw me off again.
Lovely, lovely. I'm going to look through some more of you guys' survey things over lunch. There's been some good stuff in there. So what time did it get dark yesterday? That super bummed me out. That's why we're having the windows kind of open, letting some more sunshine in. I need to live it up. The sun's
I
down.
like the shirt, Joey. Thanks. I think I gave that little. I think I
For that
like
R,
that.
will it always be the saving fund?
Yes, yep, always, yep.
Okay.
Yeah,
So it'll always be this one?
Yep, now on the test, then we'll have to introduce this other one with present value, but yep, for this one, it's always gonna be that one.
What kind of words will be in the question? Oh, it'll be like, will it be like find the amount?
Find the
of
payment
money?
amount, regular monthly payments, so
Okay.
Joe, yours is gonna be the very back one.
Alright, yeah. Thank you.
Thanks.